I'm Will. This is Nicola. And we'll spend the next half hour somewhat informally just talking through a bunch of what it takes to look at chain state and how to think about and work with the fairly large amount of state that exists in Filecoin today. In particular, we're going to talk through two tools that we've been working on as sort of exemplars of this. Nicola is responsible for SpaceGap, which many people maybe have already used and looked at as a way of understanding the state of a bunch of different miners and calculating and doing some sort of analysis of the current state of various moving parts within the network. And Statediff sort of looks at the actual underlying data that's being saved and exists on chain and helps you sort of navigate and see what's actually there and how things are organized. We'll go through three things over this half hour. I think probably the most useful thing is to start by giving you a bunch of pointers to existing data sources. So that is, what are the APIs that are available to you, and what do they give you? What is sort of easily available? Then we'll transition into understanding sort of where the data exists, how it's structured, and hopefully give you some tools to do more complex analyses and derive your own data and your own views of things as they relate to Filecoin. So what's out there already? So the first thing I want to point you to is Glyph. Glyph runs a set of nodes that provide a node API. And this gives you actually a lot of different views. This is a tool that is used by Nicola for SpaceGap. And it basically provides a set of public infrastructure access to the JSON RPC that lets you get access to state, that lets you get access to a bunch of the Lotus exported views, and really is sort of a powerful source of insight into what's going on with Filecoin. And so what you get by having these public nodes is you don't have to run your own Lotus, and so it lowers the barrier of entry for building apps quite a bit. And we will go later into what exactly this JSON RPC API is. There's a bunch of other derived data sources as well, though. So Filefox, among others, provides a JSON API that lets you look at miners and their current powers. And this is an analysis on top of state. So it's a simplification and lets you get a sense of some of these higher level statistics without directly recomputing them yourself. FileScan has a bunch of data. This gets used by things like FileStat and others to understand miner deals and so what is the going price of the storage market. So there's an API that FileStat then provides a further derived one off of the FileScan data to get sort of a high-level view of what is the price of storage. But between these two, there's sort of two layers of derived statistic data. The CodeFi storage also provides a more detailed view of storage deals as they go through. So this is letting you look at recent asks, and so this is someone's proposing a deal. Those deal proposals end up on chain, and so you can keep track in an ongoing way of proposals for storing content and how much that's costing and how long it is and reputation and so forth. So again, this is a derived simplified view that lets you not go on chain. So one of the nice things about having this ecosystem is rather than reinventing the wheel, a lot of the time you can find existing libraries and existing APIs that have already done some of the work for you. So definitely look at what's out there already. I think is sort of what these pointers are really aiming for. And finally, there's the Lotus API itself, and this in many ways you can think of as sort of the root of truth. in that this is directly reflecting, what's on chain, and it's something that you can run yourself. And so this is you're now in a decentralized thing where you don't have to trust anyone else. And we'll go through, what exactly you can get directly from Lotus. There's a couple different ways to engage with Lotus. There is a JSON API that I think both of us have primarily been using that we'll talk through. You can also access it directly through the Lotus command line client. Often has direct command line invocations to retrieve information about various parts of the network. And that can be used if you're in a more Unix or Bash or command line style environment where what you want is sort of scriptable access into state. So with those pointers, I'm going to hand it over to Nicola to talk about SpaceGap as an app and how that's working.
Thank you, Will. Hello, everyone. I'm Nicola. I lead research efforts at Protocol Labs, but this time I will show you SpaceGap, which is an application that we built originally for internal usage to monitor miners or to monitor the growth of the network and to be able to look into miners' deadlines, sectors, to try to understand whether or not there are problems. And it ended up being a very useful tool for ourselves and for miners themselves to track how their mining facilities are going. And the goal is to turn this into a dashboard for miners. And yeah, one day also for users. So SpaceGap, as Will said, uses the JavaScript library, which is called Lotus JS client, and it queries directly into the to an active node, which was offered by Glyph. And so all the data that you see here is directly pulled from a node every single time this page is loaded, and this page updates the data every 30 seconds, every new block. And the homepage lists what is the current circulating supply, what is the current power, what is the number of active miners. These are data that you can get straight from the node. And then we do some extra calculation that that for those that have worked on Filecoin for a long time, it's easy to understand. For those building apps starting now, this could be more tricky calculations, and all of the work that we're doing is open source, and I will share the link in a second. And the idea for SpaceGap is not just to visualize this information, but it's also to inspire other people to create different forms of block explorers. Filecoin is not just a blockchain where the key important parts of a block of the blockchain are the blocks and the transactions. There is a lot more. There are clients, there are deals, there is a market. And so the way we could be designing block explorers for Filecoin is not block-centric, but storage-centric. And I'm going to show you what we can do. So this is the list of top miners, the list of pre-commits and available balance. Let's go for example, into the largest miner that we have. So we display the available balance, the balance, how much is vesting, and standard stats like their total number of sectors. But then we also go into more complex calculations. For example, how many falls will this miner need to have in order to go in debt? So this miner is not in debt, and it would take them 11 million falls in order to go in debt. And they have 1 million sectors, so they would have to fail 11 consecutive window posts in order to go in that. And these are some stats that we're trying to show nicely on SpaceGap, but eventually either SpaceGap or Block Explorer will take advantage of deep understanding of Filecoin to do better visualization. This is another key visualization, which is the deadlines. Every miner must produce a proof every 30 minutes, and this is how the storage is organized. It's organized in cells of every cell here is a deadline, and here you can see how many sectors they have and more stats on the upcoming deadline. But let's see some small interesting miners. So this is a smaller miner, which has been faulting most of their deadlines. And with SpaceGap, you can just go and on the miner by using the address bar or from the homepage, searching it, and you can find exactly, you can visualize exactly which deadlines the miner has faulty. And what we can do, we can also click on one of the deadlines. And for example, let's go into this one in particular. This is the deadline 0 of this miner. And we can see that this deadline was faulty for 10 consecutive days. And this is the current state of the deadline. There is one partition. One partition is a group of 2,349 sectors. And you can see all the red sectors are the sectors that are faulty. All the black sectors are the sectors that are terminated. An healthy miner would look differently from this one. And there is also another feature which is not very well explored, but it's you can click inside a sector to see if it has deals or not. In this case, this doesn't have any deal, and you can see that the sector has been terminated, and so the sector is not able to earn more rewards in the future. And this is all the demo that I wanted to give. There are more areas that we're exploring. So for example, this is how gas is used in Filecoin. At the moment, it takes a while to load the page. So maybe we can see who are the biggest gas users, and we can see how much your miner is spending in gas daily and so on. And the last thing is the market, which is a page that is yet to be explored more. But this all using the APIs, there is no special work done. This is all front end. So if you're good at writing JavaScript front end, you will probably have the APIs make it very simple to build applications like this. You will be able to query all the prices from the top miners. And Will, I guess I will go back to you, and I think will explore more, but at the end, if there is more time left, I'm happy to dive more into the details of how we build SpaceGap.
All right, fantastic. So the next part of this that we can look at is the underlying data and get a better sense of where is this data coming from, and how is it stored on chain. And for that, one of the tools that I've been working on is something called Statediff. And so Statediff, you can access this at decentralized.app. You start by giving it either a specific tip set or state root. And those are sort of the identifier of the blocks, or you can get the current heaviest head of where Filecoin is. There's sort of two primary places that we find a lot of the information that we care about is either in the messages, which are sort of actions that are coming in from various clients and miners, and then the state that's on chain. And so the state is the state of all of the actors and sort of what's saved that exists and persists between different actions. And what this tool is doing is it's taking the raw data that you can access through the Lotus API, and it's trying to transform it into a sort of pretty printed JSON representation that is easier to work with. So when we go into the state root of this block that's at height 169,468, that's the current block, you can see that there's a few sort of special system actors. So there's a storage market and a storage power. And then there's right now almost 50,000 specific actors that exist. And so these range from people's accounts, but also multi-sigs and storage miners and so forth. So there's a bunch of different types of actors and other chains called the smart contracts. For each of these, they have their own state. And so that is in this head field. And so if we filter down to the storage miners, we can find a storage miner that has a bunch of balance, and we can sort of look into what is stored about it. So in this case, we see that it has a bunch of info about who owns it. And then it also has its information that's stored about the sectors that it has and the states of those sectors. And then it also has its list of deadlines. And so this is another view of what Nicola saw, and it's not nearly as pretty, but this is the raw sort of form that this is stored. And looking at this view of the various items of data and how they link gives sort of that underlying developer view of, oh, if there's some new piece of information or some new connection that I want to code together, where are those actual pieces of information and how do I link them? So this is a tool for that exploration primarily. So this was the state root. The other thing to note is that these are V2. If we went back to an early state root before the upgrade to of our actor code that happened in the week before mainnet, you would start seeing storage actor V1 state root actors and that have not been migrated potentially. If they haven't been active in some cases. And so one thing that is worth noting is that state will change over time. And the other part is the messages. So this block has a long list of messages that are the mutations to state that have happened at this time. And for each of those, you can see who sent the message. And then this also attempts to pull out what the encoded parameters are based on the type of message. So in this case, this is a prove commit sector message going to a storage miner, and the encoded parameters that were sent indicate the proof and the sector for this message. So this tool is doing a bit of additional interpretation beyond just the raw data, which would be this. It's trying to link up and say, oh, this to address, which is all that's specified, is actually a storage miner. And from that, I can interpret method 7 as meaning that this is attempting to prove a commit, and I can interpret these encoded parameters as a more structured data item. Cool. So those are sort of the main things that are perhaps of interest in this tool. I guess the other one that's worth saying here is for each of these items, if you inspect and look at what's happening in your network view, and I apologize that you now can't see this, but as I expand any of these, it's making a request, and you can directly make these requests to ask, what is the content of a given SID, and a SID here is a content identifier. And so if you've got a SID and you don't quite know what's in it, the other thing that's sort of useful here is you can say, oh, I've got this SID or hash of items, what is it? And this will give you a JSON response to that. It does want you to say in the URL bar, I think that this is a message that I'm trying to interpret. If you don't know how to interpret it, you can always just say unknown. And what it will do then is it will decode the CBOR. So it'll give you a pretty printed thing, but it won't know what the fields are. So you'll just get sort of a more generic representation. Than if you do know, in which case it can say, this is a message, and here's how to interpret the parameters, and here's where it's going. So it'll do more work if you give it a hint about where in the state that is Filecoin it is. Cool. So we showed you a cool block explorer and a thing that you can do with it. We showed you an additional diagnostics tool that you can use to sort of introspect the state of Filecoin. But if you're going to try and extract or make a new method, where do you start? And I think the place that I've started in building my stuff is Lotus, and that's probably as good a place as any. And in particular, you can look at the Lotus API. And the Lotus API has an API full file. So this is just, you go to Lotus API full. And this lists all of the methods that you can call. So you can ask, what is the head? And that will give you a tip set. You can ask, give me a block. You can get the messages in a block. You can get the parent messages for the block before the current block. If you've got a height, you can get the tip set that's at that height. You can read individual objects just as raw bytes. And this is sort of the primary thing that Statediff is doing. You can get individual messages. And so these chain things give you a bunch of information about sort of structured information about what's going on at various points in time. In addition to those, there's a second set of methods called state. Let me scroll to where these are. They're in here somewhere. Yeah. So you can get the state of a specific actor or smart contract. You can read the sort of contents of it. You can then also get some more structured information, like the specific sectors in a miner and active sectors and deadlines. And so these ones down here are again convenience methods that are more structured information. All of these methods are methods that are exposed on that public glyph node and also would be exposed on api.chain.love, which is another public endpoint for the Lotus API. These comments and this list is sort of canonical. This is what exists in reality. I would be remiss if I did not also point out that docs.filecoin.io is a great resource that provides additional documentation and use on a lot of these. So you can go into the build and into the reference, and these will provide a bunch of how you can run your own, and along with what the APIs are, and really provides a great starting place for working with this API and provides some more structured information on how to interact with these various methods. So one thing that is true is that API surface to actually understand what's happening and what sort of form the data is going to come back to you in is scattered across a lot of code. So for instance, once you get into a specific miner and are looking at, okay, what are the fields in miner deadlines, that process ends up being a little bit painful because you are looking into a different repository called spec actors typically, and that has now been versioned so that we can handle network upgrades in that it will change at different block heights. And one of the things that means is there's not an obvious canonical place that you will directly see the various structures of data and how they're interlinked. And so one of the things that perhaps is useful is in Statediff. So this is also open source, and this is that diagnostics tool that I was showing you. You can look at the types here, and this is there's a lot of generated stuff, but type/gen has a single place where you can find a representation of the full schema and interlinking of all of the various state objects that you're going to see. And it starts at Lotus. So it will say a Lotus block header has these fields in it. And in particular, it has a parent state root, which links to a Lotus state root. And then somewhere else, I believe in this file, it'll say Lotus state root has a list of Lotus actors. A Lotus actor has code, head, nonce, and balance. And then you can go into the specific types of actors. So I can say a version 2 miner will have these fields in it. And so this is sort of a one place that is a recomputation or a retranscription of all of the various state schemas that you can expect to engage with when you're delving through the various parts of state that exist in Lotus. And that's maybe one of the other useful points of reference that you can find. Cool. To finish off, I want to just give a couple other things that are useful things to see. And maybe I'll do this in just a minute or two and leave a few minutes for Nicola to talk about interactive notebooks. One concept that is worth being familiar with is IPLD, so linked data. This is used throughout the state. And so this is trying to think about, okay, you've got these content identifiers, which go to a record, which will be an IPLD record that specifies in an IPLD compliant structure the subsequent links that it has. And this allows for a set of generic tooling to be able to spider and crawl over the data and to select specific items of data. It's encoded using DAG CBOR. So this is a directed acyclic graph variant of CBOR, which is CBOR, but sort of is at that intersection of CBOR as the binary encoding and IPLD as the structure. The concept of how we're encoding SIDs or these content identifiers for the way to reference a record within our data store. And then the sort of more particular piece that gets used by Filecoin that you won't find directly in IPLD is a concept called ADLs, or Advanced Data Layout. And what that is it's a couple data structures for how do you efficiently compact maps or arrays that are dynamically sized. So as a miner is getting more sectors or more deadlines or various things, you've got a data structure that needs to grow. And you want that to be compact on disk, and you want parts that aren't changing to stay stable and not have to rewrite large parts of state. And so that's led to a couple specific data structures that exist in Filecoin called HAMPs and AMPs. And so those are probably the part where when you find some weird looking parts of state, you've run into one of those, and you'll likely need either a higher level request that hides those from you and goes on top of them, or you will need to deal with them yourself. So I think that's most of what I have. Nicola, I don't know if you want to take these last couple of minutes to maybe talk about Observable.
We will leave the link, but on observable.com at protocol/Filecoin playground, there is an observable notebook that you can import to make new notebooks. And it's a JavaScript-based tool. And you can use the JavaScript, you can import the previous notebook to run more queries. But the idea is that through Observable, you can play around with your with the Filecoin APIs. I'm going to show you a very high level. This tool imports Lotus in a variable called client. And then you can use the client with the ways that Will showed you before, with the methods that were in the API file of Lotus. And so, for example, in order to get the head of Filecoin, you would do a client.chainHead, and this will give you the CIDs, which is the number of the block CIDs and of the parents, the current block. So you could already, just with head, build a UI that it's useful for a block explorer, showing the latest block. And then you can also do something more complex, which is client.stateMiner power. We specify a particular miner and we pass the head.cids. So this is what we call the tip set key, the set of nodes in the set of parent nodes to identify the position of a block. And with this, we're now able to just show what is the miner power, what is the raw byte power, and the quality adjusted. And this document has a lot of other examples. So feel free to go around this document, fork this, or use it as your own library for the notebooks. This is a perfect way for playing with the APIs before getting to deep into this.